Hi, this is Chris. The purpose of this video is to demonstrate concrete plate design in ENERCALC 3D. Let's take a look at the model that we have set up here first. What we have is just a one-way concrete plate. We can render that in 3D. Happens to be 8 inches thick, and I believe that it's a span of about 10 feet. If I reset the model and then turn on loads, I can show that there's a dead load assigned. My dead load is a surface load. It's got 100 pounds. And then if I come back and turn on my live load, I can show that I have a 20 kip point load at midspan and off to one edge of our plate. So our analysis is currently complete. The model is solved. And what I'd like to do is take a look at some contours. So let's just look at the live load condition. And let's take a look first at displacements. So as we would expect, the displacements on the left-hand edge are more severe than those on the right, just because our point load is skewed off to one edge. So this will be important for us to understand, because we're going to select certain plates that we want to perform a design for, and we'll make the assumption that we just want to seek out one reinforcing pattern. So we'll obviously want to find those elements that are the most heavily stressed in order to decide what elements to select and design, select designs for. So I'll reset the model, and what we'll do is come to concrete design and just step through each of the different items in the menu that are relevant to plate design. First, I'll come to reinforced concrete materials. This lists the materials that have already been defined in the model. The concrete material is the one that I've assigned to these plates, and what's unique about this view of the defined materials is that it provides us with those material properties that are relevant to design. So it confirms that I've assigned an F'C of 3 KSI, and I'm using a yield stress of 60 KSI for both longitudinal steel and shear steel, if there was any in a slab. Next, I'll come to concrete design criteria, and we'll come into model design criteria. In this dialog, we can select the design code that we want the design to be based on, and then it's used to specify parameters for column design, so we can ignore all of the left side of this dialog. Beam design parameters, we can ignore those since we're only looking at plates. It all boils down to this one category here, where for plates we can specify a minimum reinforcing ratio for top steel and for bottom steel. Now, I've modeled a simply supported slab, and I've loaded it so that I know the bottom is the only place where I'll experience tension, so I really don't care too much about a top steel minimum in this case. But if you wanted to distribute your steel for temperature and shrinkage reasons, you could specify whatever value you want to try to get some steel called out in the top as well as the bottom. So I'll click OK, and then I'll come back to concrete, and we'll skip across beam and column design criteria and just come to plate design criteria. Here we can create as many different plate design criteria as we want and assign those to specific shells in the model. Notice that there's one that's already defined called default. If we wanted to use that, we could. Just to make the point, what I'll do is create a new one, and I'll name it slab. And then all we have to do here is specify not quite clear cover, but edge to centroid distance. So I'll just populate these with values of 2 for the bottom. It probably wants values for the top, even though I don't anticipate top steel, so I'll just populate those as well. And then I'll click Apply. Notice that I didn't select to assign to selected shells yet, and that's because I haven't actually selected any shells. So let's just click Apply. And then what we saw in that earlier view of the deflections is that we have 2 shells that straddle the line that our point load is on that will be the governing for the design. So let's select those and then come back to Concrete, Design Criteria, and down to Plate Design Criteria. We'll make sure that the line is selected for my slab label of Plate Design Criteria. Now I'll select Assign Active Criteria to Selected Shells and click Apply, and that assigns that to those 2 shells. Let's come back in to Concrete, Design Criteria, and I just want to focus on this Exclude Elements item for a second. What this does is it lets us zero in on only the elements that are of interest to us and exclude all of the others so that we simplify the design output and the design process as well. So it would be logical for us to exclude everything except for the 2 shells that we know we want designs for. So the easy way to do that is select the 2 shells that we want and then use this tool to invert the selection so that we get everything else selected instead of the 2 shells that we want. Then we can come back to Concrete, Design Criteria, Exclude Elements, and make sure that we've selected the option to exclude selected elements from Concrete Design and Apply to Selected Shells, and click OK. So now we've told the program that we don't want designs for any of these other items. In anticipation of the last command that we'll have to apply to these shells, I'll select the 2 of interest and then come to Concrete, Design Criteria, and down to Cracking Factors. So we want to assign cracking factors to those 2 plates or shells of interest. Notice the note down here at the bottom that gives us some reference values as suggested from ACI. I'll use the value of 0.25 for flat plates and flat slabs. So 0.25 as my input, apply to selected shells, and then click OK. So that's great. We've now assigned the design criteria that we need to perform the design. Let's take a look at Concrete, Assign, Plate Design Properties. We don't actually need to do anything in this dialog, but I just want to point out that it is a way that you can assign criteria like design criteria and the exclusion, the included or excluded status, as well as the cracking factor to selected shells out here in the model. So if we had only assigned the design criteria to certain shells but then changed our mind and wanted to come back and assign that to others, this is the easy way to do it with the assign command. We don't need to do anything, so I'll cancel out of that. Let's come back to Concrete and take a look at design input, and we'll go straight to reinforced concrete plate input. This is a tabular view of everything that we've just entered. We can choose our slab design criteria. I should point out that this doesn't change the view, but instead it becomes a way that you can apply the selected design criteria to selected shells. So don't be misled by that. The function of this is a little bit different than a drop box at the top of some of our other tables, such as results. What we can see here is a list of all the shells in the model. a list of the design criteria that's been assigned, a list of the cracking factors that have been assigned, and whether the shell is included or excluded. What we can see is that we have a lot of shells out here that have design criteria 1, a cracking factor of 1, and an excluded status. Those are all the shells that we chose to ignore. What's of interest to us is these two shells right here, 95 and 96, that have design criteria number 2, cracking factor of 0.25, and an included status. Now I can show that if we use this drop box, we can change the design criteria for the selected shell. Notice that the 2 became 1. We'll set that back to 2 just so that we keep things the way we want it. The cracking factor can be edited manually, so I can enter 0.3 and click on a different cell and we change that factor. And then the included excluded status is affected by a drop down, so that can be changed as well. The concrete plate input table is just that. It's a table that shows you how everything has been set on a shell by shell basis for the current model, and it gives you the ability to edit those settings. At this point I'll click OK. We'll dismiss that dialog, and we have done everything that we need to do up to the point of performing a design. Now I will point out down in the lower right hand corner that some of the exploring that I've done for the purposes of the video has reset the solution status to not solved, so I'll just run a static analysis again and we'll get current results. We can't get design results unless we have current analysis results. Click close, back to concrete, perform design. Now this was a very fast process because it's a real simple model and we're only asking it for designs for 2 plates, so it's already complete and we can click close. From here on out, it's a matter of looking at design results, so we'll come back to concrete, design output, and we'll come down to the bottom section that applies to plates. So one option is to look at the wood armor moments. Notice that we can take a look at moments for each shell. If we wanted our shells of interest, we could scroll down and find them in the list and pick them out. Also, remember that there's a control that we can adjust in settings, data options, to indicate whether we want information to be reported at the center only or at nodes or both. So if we change that and then come back to concrete, design output, wood armor moments, now we can get even more information for each shell. We have a report at the center and at the nodes. Also, if we come to concrete, design output, reinforced concrete plate results, we can see information for the 2 shells that we specified designs for, the design thickness, concrete strength, yield strength of reinforcing steel, bottom moments, top moments, areas of steel required in each direction for the bottom and for the top. And just remember that these areas of steel and moments are keyed into the plate local coordinate axis system. So if we want to display that, we can select our 2 shells of interest and then use the icon to display the shell local axis system. And just remember that the colors are coordinated with the global coordinate axis triad colors. So our X direction on these 2 shells is in the span direction, and the Y direction is perpendicular to the span. That can be helpful in interpreting your output and your results. Let's come back to concrete. If we come down to diagrams, reinforced concrete plate envelope contour allows us to take a look at either wood armor plate moments or required plate reinforcement. Let's take a look at the plate reinforcement for the bottom X direction, and we'll display surface only and then say OK. So what we can see is that we're in the dark red category, and that's about 0.4 square inches per foot. Just to close the loop here, let's take a look at plate results and see that in the bottom X direction, area of steel is about 0.4 square inches per foot. So the graphical and tabular formats agree. That's the only diagram that's of any meaning for a plate, and in fact there's no reporting information available for plates. And for the reinforced concrete tools category, there's really not much of interest or relevant to plate design either. The only thing that may be of any interest is the rebar database. So that's a full look at everything that's available for plate design, concrete plate design in ENERCALC 3D, and hopefully that's been helpful.